In this explainer, we're breaking down how emerging technologies make that tough journey from a simple concept to a market-ready reality. We're going to get into the critical, technical, and economic hurdles that have to be cleared along the way. This next wave of tech is so much more than just a list of buzzwords. We're going to look at what really makes these innovations tick, and more importantly, why their true power is only unlocked when they're intelligently combined. We are in the middle of a surge of incredibly powerful innovations. We're talking about everything from AI and quantum computing to the Internet of Things and next-gen connectivity like 6G. All of these are poised to fundamentally reshape entire industries. But here's the crucial point. These are not isolated trends. Their real power, their true strength, only comes out when they're combined into integrated systems. And for a lot of companies, creating those links is a massive challenge. So let's dive a little deeper, and we'll take a look at one of the most complex examples out there, quantum computing. It's a perfect case study to understand what emerging really means on a deep, technical level. The grand vision, the ultimate goal here, is to achieve what's called quantum supremacy. That's the theoretical tipping point where these machines can solve problems that are practically impossible for even the fastest classical supercomputers we have today. But where are we right now? Well, we're in what experts call the NISQ era. And that name perfectly captures the current limitations. The systems are noisy, meaning they're extremely prone to errors, and they're intermediate in scale. Now, we have seen processors break that 1,000-qubit barrier, which is a huge milestone, but even that intermediate scale is still orders of magnitude away from the tens of thousands of stable qubits we need to actually overcome the limits of this era. So, what's the fundamental reason for this noisy state? It's a phenomenon called quantum decoherence. Basically, the quantum states are incredibly fragile. The slightest disturbance from the environment, think tiny temperature changes or electromagnetic fields, can cause them to collapse. That loss of information leads directly to errors, drastically limiting the computer's power. Okay, so let's shift gears from the purely technical challenge and look at how this builds into a much broader economic problem. That incredibly difficult journey from the research lab to a successful product on the market. The ambition is definitely there. You have leaders like Peter Leibinger, who speaks from experience both as the former president of the Federation of German Industries and as a CTO, calling for bold goals to kickstart a whole new wave of innovation. And this chart just brilliantly illustrates the core problem. Data from the 2025 Innovation Indicator shows that while a country like Germany is fantastic at generating new knowledge, it really struggles to transfer that knowledge into market-ready products. There's a gap between the idea and the value creation. The key factor here is what Leibinger calls time to money. The process is just too slow. It gets bogged down by bureaucracy that suffocates the very speed you need to survive and compete on a global scale. So, how can companies actually get over these hurdles? Well, two key strategic trends are emerging that directly tackle this need for speed and efficiency. First up is platform engineering. The idea here is instead of reinventing the wheel for every single project, companies are building internal platforms. These standardize development and massively accelerate how quickly new applications can be delivered. And listen, this is not some niche concept. Gartner is forecasting a massive shift. By 2026, they expect a full 80% of large software engineering organizations will have adopted this approach. Second, there's this really fascinating and disruptive new concept emerging, the machine customer. We're talking about non-human economic actors, smart devices and systems that can autonomously purchase goods and services on their own. What's really incredible here is just the sheer scale of this change. Gartner forecasts that by 2028, there will be 15 billion connected products out there with the potential to act as customers. This is going to fundamentally change commerce and entire value chains. So, what's the big takeaway from all this? The path forward for emerging technologies is really defined by a pretty clear set of challenges, but also a ton of opportunity. First, we have to recognize that real innovation happens at the intersection of these technologies. Second, we have to tackle both the deep technical hurdles and the structural economic barriers head-on. And finally, success demands adopting new, agile strategies to accelerate that entire transition.
Ultimately, transforming technological possibility into economic reality isn't just a process. It is the single most defining strategic imperative for innovation in the years to come.